Good morning, dear students. How are you? Hope fine. Today I am going to start chapter 3 from first paper, periodic properties and bonding in elements. I finished my last lecture by discussing transition element. Today I am going to discuss about properties of transition element. Some important properties of transition element: variable oxidation number, formation of color compound and formation of complex compound, and its magnetic property. What is transition element? Transition elements are the d block elements, but it has stable ion with partially filled d orbital. Now, variable oxidation state. I think all of you know what is oxidation number. Oxidation number means the number of electrons which participate, the number of electrons of any atom, ion or molecules which participate to form any chemical bond, right? So, some oxidation number of d block elements, transition elements like chromium, it has 3 stable oxidation state: 2 plus, 6 plus, 3 plus, 3 plus and 6 plus. That means to form any chemical bond or in a compound, chromium donate 2 electron, 3 electron and 6 electron. Similarly, if you take another example, manganese, it has variable oxidation number 2 plus 2 plus 3 plus 4 plus 6. That means manganese participate in a chemical compound by donating 2 electron, 3 electron, 4 electron and 6 electron. Iron, it has 2 stable oxidation state, plus 2 and plus 3. Basically, variable oxidation state of transition element occur due to 2 reasons. Main reason is partially filled d orbital. Another reason is n-1d and ns orbital are the comparable energy. n-1d and ns orbital are the comparable energy. That means if we take the example iron, atomic number of iron is 26. That means 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Okay? So, when iron participate in a chemical reaction, then its last electron, its electron from the last outermost shell, it releases its electron from the last outermost shell. That means it releases its 2 electron from 4s orbital. So Fe2 plus, to form Fe2 plus, then electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6 and 3d6. Okay? For stability, we can write this electronic configuration as 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. For stability, since half-filled orbital and full-fill orbitals are more stable. We can write this electronic configuration as like that. Okay. For another stable ion of iron, F3+, this electron is released. That means one electronic configuration looks like that: 1s2, 2s2, 2p6, 3s2, 3p6, and 3d5. Okay, so why transition element shows variable oxidation number? Two reasons. One is partially filled d orbital. Since it is partially filled d orbital. Another is n-1d, and ns orbital are the comparable energy. Clear? Now, next topics. Formation of complex compound. Formation of complex compound. Transition element take part in formation of complex compound, and it takes part as a central atom. Okay, if we take an example, that is one of the complex compound. Its structure is like that. That means iron is transition element. Transition element takes part as a central atom in complex compound. So, since iron is a transition element, it takes part as a central atom, and cyanide okay. Iron act as a central atom, and these cyanides are ligand, and they form coordinate bond, 6 coordinate bond. They form 6 coordinate bond. Now, complex compound. Why iron form this complex compound, or any transition metal form a complex compound? If we see the electronic configuration, iron 2+, that means it releases 2 electrons to form this complex compound 2+. So, electronic configuration of its d orbital or outermost shell electronic configuration, we know d so outermost shell, iron has d orbital, 3d orbital. In 3d orbital, iron has 6 electrons. Six electron, 3d orbital of iron, and it has vacant 4s orbital and 4p orbital also. Okay, 4s and 4p orbitals are vacant. Due to the influence of unpaired electron of vacant valence shell of transition element, there is unpaired electron of valence shell of transition element, they get paired up to make vacant orbital. Okay, that means 4s, 4p and 3d orbital energy of 3d, 4s, 4p are not similar. By hybridization process, this 3d, 4s and 4p orbital energy becomes similar. Okay, what is hybridization? I will discuss hybridization later. So, this electronic configuration becomes electronic configuration of 3D becomes like that. Why? By the influence of unpaired electron of ligand. When ligand comes towards the iron, ligand cyanide comes towards the iron, then unpaired electron of ligand or lone pair. Okay, there forms some vacant d orbital, and this 2d orbital, this 4s orbital and this 4p orbital become similar energy containing orbital by hybridization. Okay, now how many vacant orbitals are prepared? 1, 2, 3, 4, 5, 6. These 6 vacant orbital gain 6 cyanide. 6 cyanide enter into 6 vacant. 6 cyanide enter into 6 vacant orbital. Okay. Like this, cyanide makes a coordinate bond with iron. So 6 cyanide makes 6 coordinate bond with iron. So I think you're clear now. Formation of complex compound. All transition elements form a complex compound, and transition elements act as a center atom, and they form a complex compound with ligand by coordinate bond. Okay, and outermost shell or valence shell electronic configuration is like that. For iron, this valence shell electronic configuration converted into this electronic configuration. That means unpaired electron, 4 unpaired electron of iron Fe2 plus become pair. Why? By the influence of lone pair electron of ligand. By the influence of lone pair electron of ligand. When any ligand comes towards the iron, then this lone pair electron, due to the repulsion of lone pair electron, unpaired electron of transition element become pair. Now, what is ligand? What is ligand? Ligand, during the formation of During the formation of complex compound, lone pair electron supplying molecules or ions are called ligand. Okay, so ligand can be ion or molecules. It can be molecules or ions. There are two types of ligands, neutral and charged. Neutral ligand, ammonia, water. Neutral ligand. Why? Since they have lone pair electron. That means electron reach any compound or electron reach any molecule or electron or negatively charged ion act as a ligand. Since ammonia and water has lone pair electrons, so they act as a ligand, but they are neutral ligand. Neutral ligand. Another ligand, chloride, cyanide. Since they are charged, so negatively charged particle, that means reach of electron, say they are negative ion ligand. Another related topics, coordinate number and oxidation number. Complex compound, name of complex compound, hexacyanoferrate 2 ion, hexacyanoferrate 2 ion, okay. So what is coordinate number? The number of lone pair of electrons supplied by ligand to transition metal ion to form coordinate bond is called coordinate number. That means how many coordinate bond is formed in this complex compound? 1, 2, 3, 4, 5, 6. So coordinate number of this complex compound is 6. Okay, that means iron form 6 coordinate number with 6 coordinate number with 6 ligand. So coordinate bond with 6 ligand. So coordinate number is 6. What is oxidation number? Compound structure is like that, FeCN6 4 minus. And these two iron form now what is oxidation number? Total number of electrons which is gains or losses in order to form a chemical bond is called oxidation number. That means iron loses 2 electrons from its outermost shell to form any chemical bond, that means its oxidation number is 2. For this compound, coordinate number is 6 and oxidation number is 2. If we write another example, tetraamino copper 2 ion. Tetraamino copper 2 ion. In this compound, copper form 4 coordinate bond with 4 ligand. So, topics Formation of color compound. Formation of color compound. Okay. If you take same ion or same element, transition element iron, for iron, electronic configuration of d orbital is like that. This position of 3d orbital is called degenerate state. Degenerate state. Okay. When any ligand comes to iron, then this d orbitals are splitted, like that. That means dxy, dyz and dzx, these three orbitals, and dx square, y square and dz square. So d orbitals are splitted in two parts. This situation is called non-degenerate. Non-degenerate state. Okay. Degenerate state means the orbital of equivalent energy is called degenerate state. During the formation of complex ions, when the ligand orbital approaches to the metal orbital, these are splitted due to this splitting is occurred due to repulsion of lone pair electron of ligand with unpair electron of transition element. Repulsion of lone pair electron of ligand with unpair electron of transition element. Okay. When any ligand comes to this transition element, then they try to form maximum number of unpair electron. That means electron from ground state jump to higher position. And 2 electron enter into higher d orbital. So there form a energy difference, delta E. They form an energy difference. Okay. Basically, this splitting of d orbital is called non-degenerate state. then there form an energy difference. This difference of energy between these two states shows remaining color. How? If this required energy change equal to the particular band, if this required energy change or delta E value is equal to the particular color, or is if delta E match with the wavelength value of any visible particle color, then complementary color of visible light reflects to our eye. Okay, I explain again. Iron is a transition element, that is the electronic configuration of d orbital, which is called degenerate state. And in influence of ligand, these d orbitals are split into two parts, that is called non-degenerate state, and lone pair electron of ligand repulse this unpaired electron of d orbital, and they form maximum number of pair. When any compound is formed like that, when any compound is formed is FeH2O hexaaqueous iron 2 ion, then unpaired electron of pair position goes to higher orbital and gains certain amount of energy. That is called delta E. If this delta E value is matched with the wavelength of any visible light, so we can see the complementary color of that visible light. So which complementary color? Complementary color, if it absorbs yellow color, so its complementary color is purple. If it absorbs blue color, so its complementary color is orange. If it absorbs red color, so its complementary color is green. Okay. If delta E, if electron absorb yellow color, so it reflects purple color to our eye. If it absorb blue color, it reflects orange color to our eye. We can see the compound orange. If it absorb red color, we can see the compound as. Our last topic is magnetic property. Magnetic property. There are three magnetic property: paramagnetic, field, and it contains unpaired electron. As example, manganese 2 plus, Fe3 plus. It contains unpaired electron. And paramagnetic, it also same, paramagnetic, same as paramagnetic, but it has maximum paramagnetic. It contains maximum number of unpaired electron and can be magnetized, and highest point of paramagnetism. It is basically highest point of paramagnetism. That means it contains ferromagnetic substance contain maximum amount of unpaired electron. Diamagnetic means pair electron. It has no unpaired electron. Copper plus nickel. It contain only pair electron, and another topic is it has no magnetic property. Okay, these are the main discussion of today's class. Thank you all, and in our next class we try to discuss about the properties of periodic table, basic properties of periodic table. If you have any confusion or any question, please comment me in comment box. Thank you.